All right. So thanks everyone for coming to today's Our Ladies Philly Lunch and Learn. Our guest today is Ella Kaye.
Hi.
Uh, Our Ladies is a worldwide organization that promotes gender diversity in our community via meetups and mentorship in a friendly and safe environment. All Our Ladies meetups adhere to a code of conduct, which is listed here, ourladies.org/COC. There are any violations, you can report this at reporting@ourladies.org. And I want to make sure we acknowledge that gender diversity for our Ladies community includes, but it's not limited to cis, trans women, trans men, non-binary, genderqueer, and agender. All are welcome here. If you want to get involved, you can go to our website, ourladiesphilly.org. You can learn about our future meetup events on our meetup page. You can join our Ladies Philly Slack, subscribe to our YouTube channel, and you can also volunteer as a speaker, mentor, or organizer. We'd love to have you. And we are so excited to have Ella Kaye today. Ella Kaye, would you care to introduce yourself?
Yeah, hi, I'm Ella. I'm a research software engineer at the University of Warwick, and I'm a fellow of the Software Sustainability Institute. And I'm reading off a slide here. I work to increase sustainability in EDI, equality, diversity, and inclusion in the R project, in particular by fostering a larger and more diverse community of contributors to base R, which is a lot of what I'm going to be speaking about today. I also run Rainbow R, which is a community that connects, supports, and promotes LGBTQ plus people who code in R and spreads awareness of LGBTQ plus issues through data-driven activism. So if Rainbow R sounds like it might be up your street, I very strongly encourage you to check out rainbowr.org, where there are all kinds of links about how to get involved in the community, to join the community, and loads more about what we do there. Um, yeah.
Yeah. So we had this, thanks so much. We had this icebreaker question that says, what comes to mind when you hear it contributing to base R? And before I turn it over to you, I think we should read a couple of these responses out loud. They say, contributing to base R, glad there are people who do it, but well beyond my skill set. Something I'd love to do, but I don't think I'm capable of. Hard things only smart people do. Uh, Something beyond my skills. Uh, Never thought something general R users could do. So there's a lot of interesting thoughts. Maybe Ella will have some thoughts of her own on this.
Oh, I
All
have.
right.
Hi. Well, thank you so much, Alan, for inviting me today, and thank you very much, everyone, for joining. So, on the point of a hard thing that only smart people can do, I'm going to take it as a starting point here today that you are all smart people, and I am going to show you that it is not as hard as you might think. Um, so, yeah, I'm delighted to get started. So, shall I go ahead with the screen share and take it away from here? Okay.
Sounds great.
All right, so I am going to be battling multiple monitors, multiple windows. I'm going to share my main desktop. If I look like I'm looking to the side, that's just me taking a peek from my speaker notes, but I am going to try not to use them for the majority of the talk. Right, hello. So I called this talk C for R users because I gave a C for R users talk at USR in 2024, and Shannon invited me to come and present that today. But that was a 20-minute talk, and I've got a whole hour now. So I've expanded the talk, and I've put in a little bit more C content, but I've really expanded it more around contributing to base R, hence my suggested icebreaker question to start with. So I think it's often fun to start a talk with a picture, and this is a picture taken at the R Project Sprint at the University of Warwick that was held in 2023. So this is a group of R folks, R
Are
contributors.
you screen sharing?
Am I not screen sharing?
Not yet.
Okay, well that's gonna really affect the talk. Okay, bear with me a sec. Where did I put my Zoom? All right, while I'm getting this sharing going, have a think in your mind what you expect a picture of a bunch of R contributors to look like.
They're gonna look like me because I was there.
Shannon was great. Am I sharing?
Yes, we see it now.
You see it? Yes, you see Shannon. You see, but what I actually see is a whole bunch of people from all over the world, of all different ages, of all different experiences levels. We have most members of our core. We have people there who have never contributed to base R before. You too could be contributors to base R. So, as I mentioned briefly in the intro, my background is that I'm a research software engineer at the University of Warwick, and I work with Heather Turner on her fellowship project Sustainability and EDI in the R project, where the overarching goal of that work is to foster a larger, more diverse community of contributors to base R. And the R project sprint at Warwick was part of that work. So, in this talk, what I'm going to do is I'm going to encourage you to contribute to base R. I'm also going to encourage you to learn C and explain why that is linked to contributing to base R. I'm going to show you some C code in base R. And more than just encouraging you to contribute to base R, I'm going to show you by means of live demo how to actually do it. And then, time depending, I'm going to outline the work of the R contribution working group. But what I'm not going to do, despite the title of this talk, is I am not going to assume that you know NEC, and I'm not actually going to try and teach you NEC either. So I'm going to do a live demo. So wish me luck here. I've set some links earlier. So we're going to be using the R dev container, which is a online VS Code environment in code spaces where you can play with the base R source code. So this is how it works. I've got here from the links, this is the link to the GitHub, and this is the link to the docs, which I've got open. And we're going to click open in GitHub code spaces. And this, you get a kind of a starting point, which is you might want to do US East or, wherever, depending on where you are. I would probably do Europe West. And then you're going to go create code space. Except I am not going to create a code space right now because that is a bit time consuming. Actually creating and setting up the code space can take a few minutes. So this is what I set up earlier. And this is exactly the point that it would be once you press that create code space button. And we are going to build R from source. So in this code space, we have listed here sort of the basic files related to the R dev container working, but we don't have any R in there yet. And the way we get R is by checking it out of SVN or Subversion. So I suspect that most of us are familiar with open source development using Git and GitHub. SVN or Subversion is an alternative version control system. And typically, when we're working in the code space, when we're working on R contribution, we want to work against the latest development version of R, which is available usually through this link here, the one in red, trunk. But I am going to show you, I'm going to show you how to fix a bug that is actually now fixed. So I am going to check out an older version of R, the stable R 4.4.3 release, where that bug was still in place. So that's what I'm going to do here with the SVN checkout. And this is going to just copy the files across. And what we have here now is in our version here, we have this SVN, which has been checked out into this top source directory. Did I mention that we've got at the start a few flags we can use? So top source directory is a link to our source directory, which it assumes is the latest version of RDevel, so it's come built in calling it RDevel. It's not RDevel in this case, it's R 4.4.3, but it's going to be called RDevel here. And then, so that's new once we run that SVN checkout. And this is the R source code. So if you've never seen the R source code before, this is where you can start poking around in it. I'm going to additionally download some recommended packages. Um, and then when we're building R, we need to work in a separate directory from the source files. So I'm going to make that build directory, which is a link to a flag here. So now we have this build directory that's come up on this in our file, and we've changed to it now working in the build directory. And then I'm going to configure the build. So all of these commands, as well as being right here on the slide, they are also in these are devel container docs, in particular around this is the building R. So there's a little bit more detail here in these docs, but the main commands are here. And while this is running, which should take about a minute, I'm going to tell you about the time when I went to a talk that was run by PositConf about doing like how to do a live demo in a talk. It's an hour-long talk on how to do a live demo, and the first thing they say was like, "Don't do a live demo." And I thought, okay, well, that's what are they going to do the rest of the 59 minutes? But it was all about how to not do a live demo, which I have studiously ignored here. All right, we are now going to build R, and we run this with the make command. And this is the bit that takes 5 to 10 minutes. So this is why I wanted to do this early in the talk, because I am now going to leave that running and go back to the rest of the slides. And we'll come back to this in a bit in a few minutes. So what is C and how does it relate to R? So C is a low-level, high-performance compiled programming language, which means that its code is translated directly into machine code by a compiler before execution, resulting in fast and efficient programmings. And that's compared to C, for example, in contrast, which is compared to R, which is an interpreted language where code is executed line by line by an interpreter, typically resulting in slower performance, but greater ease of use for tasks like statistical analysis and data manipulation. C also provides fine-grained control over memory and hardware. And much of base R is written in C, which is why we're talking about it today. R provides interfaces to compiled code. And in particular, R has a C API to deal with R objects in C, and we'll be seeing this later in the talk. So why C? So as R users and developers, being able to write code in a compiled language enables us to write efficient code. But for efficiency, we almost certainly want to use C++ with RCPP. So if you've got some R code, you've optimized it all you can, you can't get it to run any faster, but you've got like a lot of iterations or a lot of for loops, and there's nothing you can do about it. The way to speed that up is with a language, a compiled language, but working with C++ and RCPP, RCPP provides a lot of like syntactic sugar to make working with a compiled language feel a lot more like working with R, and it also takes away a lot of the headaches around memory management. So for efficient code, probably not C, but for portability, C is good because if you've written some C and then you can call it through R, but then maybe you can also call it from Python or the like. So I'm not really going to be talking about C in terms of writing compile code to speed up R code, but I am going to talk about C in the context of the kind of C that we might see when we encounter it while debugging or when looking at the R source code. So because a lot of base R is written in C, if we find a bug in R and we want to find the root cause of that bug, chances are we're going to hit upon some C code. And being able to write a bit of C or edit some C that other people have written will enable us to propose a patch to the C code to fix a bug or to add a new feature. And I am going to give a couple of examples of that now. Right, so the first of these, this is a hex code in its canonical 6-digit format, giving us this lovely shade of bluey green. But there is a recognized shorthand for such 6-digit codes where you have like 3 pairs of numbers, of repeated numbers, which is this 6CB, which a lot of languages programs know that when they see a 3-digit hex code or potentially a 4-digit hex code, if it also has an alpha channel, that the intention is to expand it and consider it as this larger canonical 6-digit one. So just before, as in like 2 days before the R project sprint, back in 2023, there was a post that went up on Mastodon from a guy that goes by the moniker Cool But Useless, suggesting that it would be really nice to add support for 3-digit hex colors in R. At that point, if you tried entering a 3-digit hex color in any R function that takes a hex code as an argument, it would return an error. And he very handily pointed to exactly the file to change and exactly the lines of code that needed changing. So this seemed like a really good issue to take on at the R project sprint. Um, so we did it. We worked on that, and I'm going to show you what we did and how we did it. And I hope, like, my key takeaway from this example is going to be that you really actually don't need to know any C or have studied any C, as like I hadn't at that point, to be able to do what we did there. That is because there is already existing code. So this is this RGB to call function that he pointed to in the toot. And let's start unpicking this a little bit. Okay. So we can tell that this is C code. And one of the kind of easiest giveaways of this being C code is that its types are declared. So R is an untyped language. You can have X is assign, this is a string to a variable X, and then you can later change X to 3, and it just doesn't care that you've gone from a character type to a numeric type. But in C, you have to state what your types are. So in line 4, we have that R, G, B, and A are unsigned ints, for example. That's quite a lot of code here, so I'm going to highlight in on a few lines here. So in line 7, we have a C function strlen, which is string length. So in the existing code, it recognized a couple of cases. Case 9, the length of the string was 9, i.e. the hash character and then 8 digits, where those last 2 digits correspond to the alpha channel, or case 7, where you have the hash sign and then the 6 digits. And then it's calculating each of the R, G, and B, the red, green, and blue channels, through this 16 times hex digit RGB1 and hex digit RGB2. So we're using, similarly to R, the square bracket notation to index into a vector, although C is 0 indexed. So RGB1 will be the first digit, where RGB0 will be the hash character. We don't really have to know what the hex digit function is doing here to be able to amend this code. And then we get down to line 19, where we see if strlen RGB is equal to 7, then you're going to return this other function, one function. Otherwise, you're going to return something different if you have to deal with the alpha channel. So that's the existing code. And even if you've never seen any C code before, I hope you can start to think about what you might need to do in order to amend this function to be able to deal with this 3-digit case. So here's the fix. So this is the first part of the fix. So we had to add in a case for case 5, i.e. when you've got it in that shorter format but with an alpha channel, and then the case 4 for the single RGB. And to be honest, like the biggest debate that we had over at the R project sprint was whether we should write 16 plus 1 or 17 in this bracket here. We stuck with 16 plus 1 because I hope that it makes it clearer how this case equals 4 for the red channel here relates to this case equals 7. So in this case, we want to expand out. So the first digit would be also the second digit in the 3-digit format. So we're going to have 16 of RGB1 plus a hex digit of RGB1 plus another hex digit of RGB1, which is 16 plus 1 of hex digit 1. So that was the fixed part 1. And then the fixed part 2 was to take this if string length RGB equals 7, and then we transferred it from an if else to a switch, but again, we had to deal with, in cases 7 and 4, of returning the value without the alpha channel and then otherwise with the alpha channel. So not a huge amount of extra code or extra suite understanding required to add this new feature and functionality to R. That was the extent of it. Well, I mean, that was the extent of the fix to the C. In terms of actually the patch, there was a bit more that we had to do. There were 6 files that needed to change because we also had to edit the documentation. And then we put in some tests as well and updated the news file. But
I wonder.
question, yes.
Yeah, I was just saying, I wonder if you could pause there and explain what a patch is. That might be terminology unfamiliar to this audience.
Excellent. That is a brilliant suggestion. So, we will talk more about patches, and indeed we are going to create a patch later in this talk. But we can think of a patch a little bit like a pull request. So a patch is a change in the code, and a patch file is essentially the difference between the code that was there before and the code when you're finished with it, when you're finished editing it. And because if we were able to check this all out on GitHub and make a branch of it and make an edit to our branch, we would then submit that change versus a pull request. We can't do that with R because R isn't developed on GitHub. So what we do is we create these patch files which highlight the changes that we want to make, and we send them to RCore, and then we hope RCore adopts these changes, i.e. The terminology for that is to like patch in this change to the code. Does that answer the question? All right.
Yeah.
Thanks. All right, a reminder to myself to check the progress of the dev container. Yes, this is good to go. So the next thing we do, having built R, is we need to check that it actually works. And the way we do that is by running make check, and that takes like 3 or so minutes. And given that this is R 4.4.3, this is a tagged release of R, we know that the check is going to pass, right? Because they would not have released it if this check failed. But it can be the case that working with RDevel, that even if you check out the version before you start making your own changes to it, sometimes you get these problems arising. So it is good to run this and make check. Great. So we're going to leave that running for a few minutes while we carry on. Okay, are people still seeing my slides? Is this still good? Okay. Right. There was a bug in the stem function. And I think of like in 10 years of giving talks and presentations, this is like my favorite slide that I've ever put into any talk ever. So a bug in the stem function, just like take a moment to enjoy this. Okay. So what was the problem? Again, this is now fixed in the latest release of R and R 4.5. So I'm going to show you here what's happening in R 4.4.3. So here we have a vector A with a few digits, a few numbers in it. And if we call stem, which creates a stem and leaf plot, we see the stems here on the left and the leaves on the right. But this bar representing the decimal point, the alignment is kind of out here. They're not all in a row. And if we look at the last number value in A, this is this 9.96, and here we've got the 10. So we might think that there's some issue around where and when things are getting rounded and when these print widths are being calculated. And when I gave this talk at USAR in 2024, this bug was present in R at this point. We had an R Dev Day, an R Developer Day coming up, like a one-day version of the R Project Sprint immediately after USAR, and I knew I was going to be working on this problem then. So these are the slides where I was like narrowing in on trying to find the bug. So for the 3-color hex version, we were told exactly where we needed to look to find the problem. But here we have to go digging. So this is the digging. Okay, but there were two problems. So the first is this stem width issue, and the second is the case of n equals 1. So this is, these are Corto slides, and this is an executed block. I'm trying to print out a stem of 2 and then stem of 2, 2. And we see we've got a printout here for line 2, but line 1 just does nothing. And admittedly, stem of 2 would not, like as a data visualization, that would not be an interesting plot. But there's no reason not to do it, like not to produce anything. It could easily show like 2 line 0. So I think that would be what most users would expect. So let's take a look at the stem function. And for those of you not familiar with this feature of R, if you type the name of a function in R and then press enter without the parentheses, then R will print out in the console the function code. And if you are in RStudio, you can also use the view function on stem, and then that will put it in a viewer window where it will have syntax highlighting. And it was a bug in Positron for a long time that view of the function name didn't work, but I think they fixed that like 2 days ago, but I haven't actually checked it yet. So let's take a look at this stem function and what is going on here. So we've got a lot of checking of the arguments with various if statements, and it's going to stop if things are happening that shouldn't happen. But the meat of the function is actually this dot call c underscore stem leaf with as dot double x scale width and atom. So what this is doing here, this dot call is taking this function c underscore stem leaf, which is a C function, and calling it, and it's passing in as the arguments to the C function variations of the arguments that were passed into the R function. So if you're looking at R code and you ever see this dot call, that means that we are then digging down to look for some C code. And dot call is the most common way to do it. And if you ever write your own C functions and you want to write R wrappers to them, dot call is going to be the way you would do that too. But in base R, you might also see dot internal and dot primitive. Those are other ways to call C code, but they're a bit more complicated and we're not going to get to that today. Okay, so we know that there's a C function. So let's do that again. Let's type C underscore stem leaf without parentheses and click enter. Okay, that's an error. So the trick, the viewing the source code function that works for R code doesn't work for C code. So we need to somehow find this C underscore stem leaf function somewhere. And that where is on GitHub. So I mentioned that R is not developed on Git and GitHub, but there is a mirror of it. So if you go to github.com r-devel forward r-svn, that takes you to a mirror of the of the C code. So this is equivalent to what goes into the svn directory on on the code space when you check out the latest devel version. And if we look at that, we see down here this stem.c file, which seems like it's probably going to be a good place to look for that code. So a stem.c, that .c suffix indicates that that is C code. This .h is a header file, which is something a bit different, and we're not going to worry about those today. So as a tip, you can also, so you can search on GitHub if you have access to that, but you can, if you are working in the rdev container code space, once you've done this svn checkout, you can also use all of the kind of VS Code style search tools within that code space also to look for the function there. Okay, so this is what the C_stem leaf function looks like. And this is a point we get to where I think that probably I'm now showing you something that you are unlikely to have seen before. So even if you've worked with C, learned to program in C, this is R's C API. So let's take a look at this and kind of start to pick apart what's going on here. So most of what I've kind of faded out are various if statements that are also checking arguments. But what I want to highlight on here is first of all, line 1, this sexp. So at the C level, all our objects are stored in a common data type, which is the sexp or S expression. And I've heard various people pronounce it in various different ways, but I'm going sexp for S expression. So all our objects are S expressions. So every C function that you create must return an sexp as an output. And that is what this very first word sexp is doing here. It says that the return type of this function is going to be an sexp. And all of the inputs are also sexps. And then I think we can start to pick our way through some of this as well. So even though there are these kind of like container sexps that are like the general overarching type, there are also like specific types. So among like as subclasses of S expressions, for example, real SXP, well, if the type of X is a real SXP, what you're really asking there is, are you dealing with a double or something similar to a double? And I think there are 23 different SX different types, but like don't quote me on that, and I will have to check. But we do some checking of that kind of stuff. And then we do some saying, and then we get down to another function call. So here we are calling stem leaf. So this is going to be another C function, but this is going to be pure C. The wrapper function here is using our C API. And then when we're passing in real of X, this real all in capitals. If you see something all in capitals, you know you're dealing with the C API. It's taking this X, which is of type sexp, and it's exposing the real values, i.e. the doubles, the numeric values underneath that. So, okay, we're digging. We've looked at stem, we've looked at C stem leaf, and now we need to look at C_stem leaf. So that exists in the same file, and this is a long function. There's a lot of code here. So I am going to just narrow down a little bit on some key parts. So it looks here, we might have found the source of the problem of the case where n is 1. It's just returning false at that point. And then we see some comments that the original authors of this function put in to like find the print width of the stem. and find the starting cell. So in really quite a long function, I've cut out quite a lot of the code. We seem at this point to have narrowed down on where the issue is. And this is the point we were at where I gave the talk in 2024. So let's fix it. Let's fix n equals 1 as a demo of using the code space. So we are looking here for the stem leaf function. And this is the call here. So I've just used the VS Code search functionalities to find that. And we are going to go down to line 60 to 61. If n equals 1, return false. Ooh, but before we do that, I'm going to go back to the final point in my how you work with the code space, which is point 7. We've done make and we've done make check, but we also want to be able to run R in this code space. And the way we are going to do this is by running this built into this RDev container has this which R command, which is going to give us the option to either work with the release version built into this container, which, to be fair, does need updating. And I think the RDev container team are on that, or the RDevel version, i.e. the version that we have checked out and we're going to be working with. So we're going to do that. We're going to want to work with the version that we're playing with. And then if we go here and we see down like on the bottom of my screen, I'm hoping people can see this here, we've got this R not attached. And if we click this R not attached, it's going to load R for us, and it's going to load this RDevel version, which as we see here is actually the 4.4.3 version. So if I type stem of 2 here, nothing's happened. Right. So I'm going to then quit out of R in this code space and go back to the terminal. And we're going to delete these lines. Okay. So we've made a change to the source code, which means we now need to rebuild R. So we build R with make. Last time it took 5 to 10 minutes, but that was building all of R. Now it's only going to kind of take into account the changes that we've made. So this should go relatively quickly. And then once it's done this, I would typically run make check to make sure that any of the changes that I have made haven't like inadvertently broken R. I'm not going to run that again now because that will always take the full like 3 to 5 minutes to run. And I am pretty confident that by deleting those 2 lines of R, I haven't broken R. I mean, I might have broken some example somewhere, but it's unlikely, and I mean, I know that this doesn't break R, but I'm not going to demonstrate that now. Right. So now let us reattach R. And now let's look at stem 2. Fingers crossed. We get a printout for that case. There we go. We fixed base R. Well, we have fixed base R in our local, in the dev container. So now what? We've seen that our changes work, and this is where we come back to talking about patches. So we need to create a patch, which is a file which shows this difference. So this is what you run to create a patch. You go into the source directory, you run this svn diff command and save out a new file into the patch directory. And I'm then just looking to see what's in the patch directory, and it is this. I've called it, like, it's good naming practice to name it with the bug number as reported on Bugzilla. I'll talk about Bugzilla in a sec. And then in this case, because there are a few different issues, I've named it the n equals 1. And if we look here in our patch directory, here's that file. and it shows the changes. So these minus signs here show, so it shows the difference between the original checkout version and the working copy, and it's going to show the changes. And the changes are minus for deleting. These are the lines we deleted. If we'd added lines, those would appear with the plus. This is still only in the browser in this code space. So we need to get it out of the browser, and the way to do that is to right click on it and download it. So I'm going to allow that. And if you, I think you still see my whole screen. Here we go. Here's that patch file. And because I gave this talk a few days ago, it's got a different copy of it. So that's the patch file that I've just opened up in any old text editor. So, right, we've created a patch. Now what do we do with it? So we can't do a pull request, as I've said, but we can submit it to Bugzilla. So in this case, this is bug 8934. And if we look on Bugzilla, this is what the R core team used to track bugs. And this was bug 8934. So if we search for that, this is now closed and fixed, but you haven't, and you see the discussion here that kind of precipitated this issue. And you can add comments and add attachments. So this is a patch that we submitted after the dev day. This is the one that fixes the non-alignment of the vertical bars. But you upload it to there, and then hopefully somebody from BaseR will accept that patch and actually incorporate those changes into the R source code. So I've got a link here to the R development guide, which contains a lot more information on kind of the step-by-steps of how you do it. I've highlighted a couple of particular chapters here, one on reporting bugs and one on the life cycle of a patch, which goes into all of that in much more detail. And I'll just say, in terms of the other part of the STEM fix, so this is now evaluated under R 4.5. We fixed that too. It was about 10 lines of C code that we changed to do that. But although it wasn't a lot of changes, it is quite hard to explain because there were lots of variables and it was fiddly. But if you're interested in looking on that, I've got some links in the slide to those to that patch. Okay. So
I guess
I'm gonna, yeah, go on.
there's a couple of questions if we want to. You want me to save them or you want to go through this?
I was almost going to stop for questions.
All right, go ahead then.
Funny. So I did want to point out that we're running a C study group. And if you're interested in that, there's kind of links online to that. We work mostly through the Harvard's Excellent CS50 course. And then with an additional week on our C API. So there's a link there for that. I've also put in the slides a bunch of links to our resources around our C API. And I think I am not going to do the section on the R contribution working group because I'm conscious that we are out of time. But if you're interested in that, the link to my slides, I'll just go right down to that, to my last slide. The link to my slides is lk.github.io/c-4r-r users 2025. And I would also encourage you to take a look at contributor.rproject.org for which has a lot more about our contribution in general, and then our meetup as well for all the different events that we run. We are also on Mastodon. So all of those links in those slides. Thanks. Woof, that was a lot. I hope that was okay.
It was wonderful.
Thank
Thank
you.
you so much. All right, we have a tangential question about the STEM function. I'm curious why anyone would use the STEM function in the wild. Any thoughts there?
Ooh, yeah, it's so one of the things that's nice about the stem and leaf function is it's great for like really small data sets where you actually you can see every single data point represented accurately. It also gives you a really nice distribution of the data. So it looks like you get that sort of a distribution curve whilst also seeing the exact values. But you're right, like it's not a very common data visualization these days.
Yeah. We have another question. Do all contributions to R have to be made in this dev container, or is it just widely used due to convenience documentation that comes along with the code space?
Yeah, it is definitely convenient. It is also possible to build R from source on your computer and work there, but that requires a big tool chain, which is just like taken care of in the dev container. So the R dev guide, which I had the link to the slides there, goes through the process for doing that, I think on Windows and Linux. It's harder on Mac, and that's not built into the R dev container. Sorry, that's not built into the RDev guide, but there is a document, like a working document that goes through that. So I will very quickly pull up the link for that. So that's on GitHub under the RDevel under our contribution working group. There we go. I knew that would come up kind of quickly in my history. So if you're interested in building R from source on a Mac, then you can do that. And then on that link. More
I
questions?
was one, yeah, I was wondering if you could speak about the process for a little bit, especially with your hex code example.
Mhm.
You saw a post on social media where someone had this idea that would be an improvement. But how does that like idea like get executed in reality? What is the process that goes around that?
That is a great question because not all posts are going to get picked up by somebody going to an RDev day 2 days before an RDev day. Yes. So a good place to start often is with the our contributor office hour. So once a month, Heather and I run this office hour for folks who are interested in contributing to R, who just like want a friendly space to chat about how to do that. So we can, if you bring it there, we can guide you through that process. I've got a slide about the R contributor office hour that I didn't get through to talking about in that slide deck. Um, so that's one way. There is also an R contributor Slack group where people can post and get answers to questions. So the guide to joining that Slack group is on the contributor website. So just let me post that link again. Um, here we go. So if you take a look at that link, there's a on the left there, there's like a link to a page about the Slack group. There's actually, if I just share my screen again for a sec, maybe. So here we go. So here's the R contributor website. So you've got the Slack group. So this is a guide to getting onto the Slack. You have links here to the R dev guide. I haven't talked at all about our contribution through translation, but there's a whole project about that. More information about the R contribution working group and various tutorials and demos. Yeah, and here are all our events, including the dev days and sprints, the office hours, the C study group, and meetings with the R contribution working group. So you've got all of that at your disposal. Or ping me an email. I'm always happy to chat about helping people get started contributing to R.
Yeah, you just got to take the first step.
Yeah, absolutely.
Reach out.
Um, so yeah, like to go back to that starting point about like it feels like a really scary thing to do. I think a lot of that because the infrastructure is a bit unfamiliar, like people are used to Git and not Subversion. The R core team like might feel a bit distant and unfamiliar with but the R contribution working group is really looking to bridge that gap between contributors and like potential contributors and R core.